Okay, so we're talking about percent composition, molecular formula, and empirical formula. So we defined all of what that was in the previous video. So now let's work on an example. So it says, what is the molecular formula of a molecule with a molar mass of 110 grams per mole and a percent composition that is 65.5% carbon, 5.5% hydrogen, and 29.0% oxygen. Okay, so we are asked what is the molecular formula? And we are given the percent compositions of the 3 atoms in this molecule. So we cannot calculate molecular formula from percent composition. The first thing we have to do is we have to calculate percent composition to the empirical formula. And then from the empirical formula, we can calculate the molecular formula using the molar mass. Okay, so let's talk about how we do that. Percent composition to empirical formula. So remember, the percent composition is the mass. It's percent by mass. So what we're going to do, the rule that we follow to do this is we are going to assume that we have 100 grams of this molecule to convert percent to grams. So we're just assuming this just for a ratio later. So just hang with me. So whatever the percent is, we are going to convert that percent to mass by assuming that we have 100 grams. This is just an assumption. So I'm going to just write down what we have. I have carbon, I have hydrogen, and I have oxygen. I have 65.5% carbon, which means if I had 100 grams, I would have 65.5 grams of carbon. If I had 5.5% hydrogen, that means I would have 5.5 grams of carbon. If I had 29.0%, that means I would have 29.0 grams of oxygen. I wrote carbon there, I meant hydrogen here. Okay, so now what we're going to do is we are going to convert these grams to moles. So here what we did was we converted percent to grams. Next what we're going to do is we're going to convert grams to moles, and we're going to do that using the molar mass of each element. So if I have, I'm just going to write this a little bit smaller, 65.5 grams of carbon, I want to convert that to moles of carbon. So I'm going to say 12.01 grams of carbon is 1 mole of carbon. So grams of carbon is going to cancel. So now I'm going to say I have 5.45 moles of carbon. Okay, so now I'm going to do the same thing for hydrogen. This might get a little off here. So I have 5.5 grams of hydrogen. The molar mass of hydrogen is about 1.001 gram of hydrogen per 1 mole of hydrogen. So that also is going to give me about 5.45 moles of hydrogen. Sorry. Let me make sure. Might be a little different. 5.5 divided by 1.001. 5.49-ish. 5.49. Okay, so now I'm going to do the same thing for oxygen. If I have 29.0 grams of oxygen, and a mole of oxygen is about 16 grams in 1 mole. This is not diatomic oxygen, this is just oxygen, and it's in this molecule, which is why it doesn't need to be in a covalent bond with itself. So 29 divided by 16, this is about 1.81 moles of oxygen. So now this tells me, these numbers here tells me we went from percent to grams to moles. Now these are this is the ratio of moles of each of these elements in this molecule. So what I'm trying to do from this is I'm trying to see what are the subscripts in my molecule. What's the ratio of carbon to hydrogen to oxygen within this molecule? And the way that I'm going to do this is I'm going to divide everything by the lowest number of moles of whatever you have. So from moles to subscripts, I'm going to divide by the lowest number of moles. So the lowest number of moles is 1.81. So I'm going to divide 1.81 by 1.81 and I'm going to get 1. So my subscript for oxygen is 1. I'm going to divide 5.49 by 1.81. Let's see what we get. 5.49 divided by 1.81. It's 3.03. So this might not be a perfectly whole integer. You're going to round to the nearest integer. It's going to be 3. And now I'm going to do the same thing. 5.45 divided by 1.81. And it's 3.01. 3. So now what these are the subscripts. So now when I write this molecule, it's C3H3O1, but you don't need a 1 there because a 1 is implied. Now what we've just done is we've just determined the empirical formula. So this is a little tricky. We were given the percent composition. We assume 100 grams to convert percent to grams. We use the molar mass of each of these elements individually to see how many moles of each of these elements we would have. We divide by the lowest number of moles to get the subscripts. So this 3 is the subscript here for carbon. This 3 is the subscript here for hydrogen, and the 1 is the subscript here for oxygen. So remember, the question says, what is the molecular formula? So remember the molecular formula, we determine what the molecular formula is by determining what is the factor that we multiply the empirical formula by to get the molecular formula. So remember, it's molecular formula, which we know this is the molar mass of the molecular formula. This was given to us in the problem, is 110.0 grams per mole. We're going to divide that by the molar mass of the empirical formula that we calculated. So let's see what the empirical formula of what the molar mass of our empirical formula is. So we're saying C times 3, so 12.01 times 3, plus hydrogen times 3, 1.001 times 3, plus 1 oxygen, 16, 55.033. So I'm going to put 55.0 down here. 55.0 grams per mole. So now this is going to give me the factor by which the empirical formula is related to the molecular formula. So 110 divided by 55 is 2. So 2 is the factor by which the empirical formula is related to the molecular formula. So I'm going to take everything, I'm going to multiply it by 2 to get the molecular formula. So that's going to tell me the molecular formula is C6H6O2. So you will be given percent compositions in percents. You will assume 100 grams so that you can convert percents to grams. You will use the molar mass of each of the elements individually to see what the mole ratio of all of the elements in the molecule are. You will divide by the fewest number of moles to get the subscript for the elements in the molecule. Then you'll use the given molar mass of the molecule to see what's the ratio, what's the factor by which the empirical formula is related to the molecular formula. You will multiply by that factor, and that will give you the molecular formula. So this is something that you'll see again. You will be given similar information that you're given in this problem and asked to solve for molecular formula.